Okay, so 233, this is our project. We basically programmed this board with what we call RAT MCU. It's an 8-bit MCU to control a bunch of different things. What we did for our final project was output a PWM to control a servo, and our input is via the keyboard, and we can use numbers and also A and D for left and right control of the servo. So right now we're at 1 degree and we can count up, and you can see that the servo is
ever so slightly changing.
Yeah, I can move that out there so you get a better downward angle on it. It's actually jumping a little bit because the motor's spinning.
Yeah, we can see it move.
Anyways, so that's that, and you can see it counting up on the 7-segment display. And then if we wanted to jump directly to an angle, we can enter it over here. So say we wanted to go to the angle 0. We have to enter 3 keys for that. So 3, it goes to 0, and that's our 0 angle. And you'll see in a second the 180-degree angle is over here. So we'll jump straight to 180 degrees, and you can see the full range of the servo. And there it is. Okay, let's go to 90 so we can get that kind of straight in the middle again. Oh, it looks like I was pretty much on. So let's just keep it on there and watch the servo update. So let's go to 45 degrees. Right there, and we'll go to 0 degrees again. And we'll go all the way to 180. Boom. Now let's look at the oscilloscope and explain the pulse width.
Go for it.
All right, so I wanted to show everyone how the signal works. So the signal for servo control is generally around 50 hertz, 47, 50, up to 100. I think even higher. It could go up to about 200 hertz, and then you vary every right now I believe this is roundabouts 20 milliseconds. You have a pulse, and you vary the length of that pulse, which will give you, which is interpreted by the servo, and thus and it will update to an angle every time this updates. So there's a pulse width for every angle. So let's actually do that. I'm going to modify this on the board. Right now we're at 180, so that's going to be the largest pulse width, and I'm going to go all the way down to 0, which is about, should look about like half of what you're seeing there. So the width of that slice is going to go down to about half. Whoop, there you go. Cut it in half. Okay, so right now we're going to update that pulse width by using the arrow key, and just so you can see about how fast everything responds. So a lot of the delay here is caused by the update time of the keyboard. So here we go. Right now I'm holding down the key, and that is our signal growing.
You see that the width of the pulse is getting larger with each increment of the degree.
So right now we're at about 45 angles.
Okay, so I think
That's good enough. I think that pretty much wraps everything up right there. So.
Okay.